Dear students, in last video we just discussed about different type of hardness and different type of water and estimation of hardness. In that estimation of hardness, we are just calculate total hardness and temporary and permanent hardness of water. So now we have the temporary hardness and permanent hardness of all water samples. Now the problem is created. How to remove the hardness? The hardness is removed by internal conditioning as well as external conditioning method. Internal conditioning is nothing but just the removal of hardness making ions by using chemicals. Just adding any chemicals or some particular chemicals just remove the hardness making ions, but it creates a lot of harmful effects. So best method is external conditioning method. The following 20 minutes we just discuss about external conditioning. Just in this external conditioning we just use some ion exchange resins for removal of hardness making ions. We know already the hardness making ions is nothing but maybe cation or anions. Cations examples the calcium and magnesium ions, and anions like chlorine and sulfate ions. So our problem is just we need to remove calcium and magnesium ions and chloride and sulfate ions. It's examples of cation and ions present in the water. So just we are going to remove that cations and ions by using ion exchange resins. Ion exchange resins is nothing but it is a polymer. Just it's a long chain molecule with cross-linked structure and microporous structure. So definitely that polymers containing microporous. By using this polymers, just we remove cation and anions from the hard water. So this external conditioning method name is called as ion exchange method. In this ion exchange method, we are using ion exchange resins. This ion exchange resins contain cation exchange resin and anion exchange resin. The cation exchange resin is example is sulfonated gold. And sulfonated polystyrene. And the example of anion exchange resin is urea formaldehyde. And quaternary ammonium salt. Quaternary ammonium salts. It is the example for cation exchange resin as well as anion exchange resin. By using this cation exchange resin and anion exchange resin, just we easily remove cation and anions from the hard water. Okay, just first of all cation exchange resin. Cation exchanger. Cation exchanger is represented as RH2. Definitely the cation exchange resins containing COH group and SO3H group. In this COH group and SO3H group, the H is replaced by the cations like calcium and magnesium ions. This H is replaced by calcium and magnesium ions. And then the next one is anion exchanger. The anion exchanger is represented by ROH twice. Definitely this anion exchanger containing NH2 and OH minus groups. This NH2 and OH ions replace the chloride and sulfate ions. Okay. Now we are going to draw the outline diagram of ion exchange method. This is the outline diagram of ion exchanger. So here this is two column is there. The first one is cation exchanger column and other one is anion exchanger. In this first column, we filled that sulfonated gold, and then the second column is filled by urea formaldehyde resin or quaternary ammonium salt. Both of them polymer. Already I said these polymers are very long chain molecule with this containing microporous structure. So it is filled up by sulfonated gold and it is filled up by urea formaldehyde resin. Yes, it's a very simple diagram. Here just we send the hard water sample. The hard water sample is go through the cation exchange resin. Just what happened immediately, the cation exchange resin containing the COH group or sulfonated group, just it is replace the calcium and magnesium salts present in the hard water. Okay, now the outlet is we are getting only cation free water. So just in this water we collect only cation free water, just this water containing only anions. This anion water is sent to second column. This anion exchange resin just remove the anions like chloride or sulfates. So finally we get demineralized water. So in the first column we just remove the cations and in the second column we just remove the anions. What happened? What is the reaction is going on here in cation exchange bed and anion exchange bed? Just what happened? Nothing, very simple. Just already I said we just represent the cation exchanger as RH2 and then the anion exchanger as ROH twice. In the reaction, just we simply represent the anion exchanger as ROH twice and then the cation exchanger RH2, because we are not able to write the whole diagram of sulfonated gold and whole molecule of urea formaldehyde in the equations. Okay, just the cation exchange resin diagram equation is RH2 is the cation exchange resin. It is react with your calcium chloride present in water. Just it is remove the calcium Ca and then to HCl, same as RH2 react with magnesium sulfate present in our water. It is converted to RMg plus H2SO4 and then sodium chloride or Na plus HCl. It is for cation exchanger. In the anion exchanger, the anion exchange represented as ROH twice. It's react with your chloride or sulfate. It forms Cl2 plus 2H2O, and other one RH2 is H sulfate ions. It forms 2H2O. Just listen. Here what happened? This is cation exchanger. It is react with your calcium chloride. It is present in your water. Okay, in your add water. This calcium ion replaced the H plus from the RH2. So it forms RCA and then 2HCl. Okay, and then same as suppose your compound, your water containing magnesium sulfate means this RH2 react with magnesium sulfate. The magnesium ions replace the proton from your sulfonated gold or sulfonated polystyrene compound. These protons are removed and then it forms RMG and then H2SO4, same as sodium chloride also. Same as in the anion exchanger bed, it is containing ROH twice. Already we have the water, suppose this is water containing HCl and H2SO4. The HCl and H2SO4 making chlorine and sulfate. This chlorine and sulfate removed by this OH twice. Thus the OH twice replaced by chlorine to forms RCl and RSO4. Okay, now finally we get demineralized water. Okay, after 1 year, what happened? Your cation exchange bed and anion exchange bed is fully exhausted. The cation exchange bed fully exhausted by cations, and then anion exchange bed fully exhausted by anions. All the ROH2 and ROH2 replaced by calcium and magnesium ions. The cation is replaced by calcium and magnesium ions, and the anion exchange is replaced by chlorine and sulfate ions. After 6 months or after 1 year, it is fully exhausted by cations, it is fully exhausted by anions. How do we regenerate? Nothing to worry, just it is replaced or regenerated very simple manner. We no need to change cation exchange resin, we no need to change anion exchange resin. The regeneration process is very simple. The cation exchange resin is replaced by HCl. And then the anion exchange resin are regenerated by using sodium hydroxide. How it is replaced? How it is regenerated? By using HCl and sodium hydroxide. Very simple. Now after 1 year, example, after 1 year, the cation exchange resin is fully occupied by RCA or RMG, right? And then the anion exchange resin fully occupied by RCl or RSO4. Correct. Now the cation exchange resin containing RCl, RSO4 and the anion exchange resin containing RCA and RMG. Now just listen what happened. Just in the cation exchange resin we are adding HCl and anion exchange resin we are adding sodium hydroxide. What happened after adding HCl and after adding NaOH? Just listen the reaction. We are just get the cation exchange resin. The cation exchange resin fully occupied by RCA and RMG, right? So RCA and RMG. Now we are adding HCl into cation exchange resin. What happened? It is converted into RH2 plus CaCl2. The RMG also converted into RH plus sodium chloride. So we easily regenerate the cation exchange by adding HCl. Same as anion exchange resin, just we are adding sodium hydroxide. The sodium hydroxide replace the chlorine. So, the calcium and magnesium and chlorine are replaced by HCl and sodium hydroxide respectively. So, by using this method, we are easily remove all the cations and anions. Okay, just we are passing the water into cation exchange bed, just it is absorb the cations and it gives cations free water. This cations free water are sent to anion exchange resin, just it is absorbed the anions. Just finally we are getting demineralized water. That is, demineralized water does not contain any cations and anions. It is ions free water. It is able to use all purpose like cloth washing or drinking, as well as any purpose. We are able to even boiler feed water as boiler feed water also. So, you are getting ideas about how to remove the cations, anions from water. Okay, after use the instrument, finally we are able to regenerate the cation resin also. So, after 1 year, after 2 years, we not need to change the cation resin. Just we are adding HCl and sodium hydroxide. Just it is remove all the cations and anions. So, it is very useful method. What is the advantage? Definitely all the instruments or all the methods having some advantage and some disadvantages. So, in this method having some advantage and some disadvantage. What is the advantages? The first advantage is this method is very useful to remove all the cations and anions from the water. And then the second advantage, just we are getting the hardness value up to 2 ppm. We are getting hardness water up to 2 ppm water. So, it is very useful for all purpose. By using this water, we are getting this water from the ion exchange method. It is very useful. So, what is the disadvantage? The disadvantage of ion exchange method, we are not able to remove iron salts from the water, and the equipment cost is very high. So, both are two disadvantages there. One is we are not able to remove iron salts, and the instrument cost is very high. So, it is the disadvantage of ion exchange method. Otherwise, it is very useful method for remove the hardness of water. So, now we are getting all the ions free water. So, the ion free water is able to use all lab purpose and drinking purpose as well as washing purpose. So, then the next thing we are going to discuss chemical action of soap. In this chapter, we covers what's the different type of water and then different type of hardness and estimation of hardness as well as how to remove the hardness. Finally, we get ions free water. By using this ion free water, just we are going to wash the fabric. Already I said the hard water does not produce lather with soap solution. So, just we are remove the hardness making ions. Now we are getting soft water, so no problem for making lathers and for removing the dirt. Just water only is not enough for removing the dirt. Just we need any detergent or soap for removing the dirt. Okay, what happened? Now we have in this hand we have water. In this hand we have detergent. How to remove the dirt from the clothes as well as our body? Just here some chemical action is going on after applying the detergent in water. What is the chemical action is going on? Actually, our detergent containing two parts. One is hydrophilic part and the other one is hydrophobic part. The hydrophilic part is react with water. The hydrophobic part is react with your dirt. The example of hydrophilic part is COONA, and then the hydrophobic part example is fatty acid. This fatty acid, the hydrophobic part is react with your dirt. The hydrophilic part is react with your water. It is easily soluble to water. This hydrophilic part make the water as easily what. The hydrophilic part make the water is spreading into your cloth. What increase the spreading activity? Just listen. Actually, it is your dirt part. Okay, it is full of dirt. Your cloth dirt. Okay, already I said your detergent containing two parts. One is hydrophilic head and hydrophobic tile. This hydrophobic tile is react with your dirt and the hydrophobic tile related with the water. Okay, what happened? This fatty acid group, that means hydrophobic group, is react with your dirt and it is removed from the cloth. And then the hydrophilic head is washed into that water. It is react with water and it is soluble the dirt into the water. Now you are getting idea what happened. Your dirt is there in your cloth. Just guess it is a cloth. Okay, in the cloth containing dirt, this dirt is react with your hydrophobic part. The hydrophobic part remove your dirt from the cloth. Okay, and then now cloth is free from dirt. The dirt is where you are going. Just the dirt is react with the hydrophobic head, is containing hydrophobic part also, just it is soluble in water. So now we are getting dirt free cloth. Okay, the example of hydrophilic part is COONA. Definitely your detergent containing COONA group. And your hydrophobic part example is fatty acid, long chain fatty acids. It is hydrophobic part, it is hydrophilic part. It is the total chemical action of soap. Suppose in your dirt is not removed by detergent. How to it remove? No problem, no panic. We have lot of organic solvents. By using this organic solvent, we easily remove the stubborn dirts. Just example, suppose your cloth is dirt by some bloods or tea or oil or grease or rust. Means don't panic or don't hesitate, just the blood or tea dirt or oil dirt and rust dirt is easily removed by some solvents. The blood dirt is removed by hydrogen peroxide. Just take the hydrogen peroxide, is available in medical shop or somewhere in our lab. Just add the hydrogen peroxide in the blood, just it is removed, or suppose using ammonia NH3, and the tea dirt is removed by vinegar solution. And then the oil dirt is removed by acetone or sodium hydroxide or potassium hydroxide. The rust dirt is removed by lemon. Just cut the lemon and rub into the dirt place. Okay, so just it is easily removed the rust dirts. So just normal dirt means we are using detergent, just by using this chemical action, just the dirts are removed from both. Suppose it is stubborn dirt means just we are used solvents, H2O2, ammonium, vinegar or acetone or citric acid. By using this solvents, we easily remove the stubborn dirts. Okay, clap, no problem. In the body, just we are using soaps. So what is the difference? The soaps and the detergents. Just we are giving 5 different points. What is the difference between soap and detergent? For soaps, we are using for skins, and detergent we are using for clothes. So next to 5 minutes, we are going to discuss about what is the difference between soap and detergent. Just soap, here detergent. The first point is soap is made up of sodium or potassium salts of long chain carboxylic acid. And then the detergent is made up of ammonium or sulfonated salts. The second point is there lesser chemical action. It is better chemical action compared to soap. The third point is it is made up from animal fat or plant fats. The detergent is made up from petrochemicals. So we are not used in skin purpose, the detergent. Soaps are easily biodegradable. But the detergent is less biodegradable. And then the last point is the example of the soap is potassium palmite. The example of detergent is sodium lauryl sulfate. So this 5 point is the difference between soap and detergent. In next video, we are going to discuss what is the different chemical composition of soap. The chemical composition of soap is builders, surfactants, bleachers, and some perfumes. So next class, just we are going to discuss full of what is the chemical action of soap, and one more important thing, what is mean by stiffening agent. Okay, we will see in next video. Thank you.